I wanted to run through corrections for the work that I posted yesterday. A couple of you emailed me expressing a bit of confusion, so I wanted to make sure that we're all clear on this, because as I said, and I told you yesterday, one question on your exam next week is going to be about functions, so you're going to be expected to be able to do something similar to this. So I want to make sure that we're all happy and comfortable. Now this stuff is no different. You've done this at junior cert, okay? The question might be a little different, but the process is exactly the same. So the idea is very simple. We take a function and we take a domain. So you can see in this problem here, I've got the function as 4x minus 3 and the domain is from minus 3 up to 4. So you can see what I'm saying. I have to graph the function from minus 3 to 4 using all of those values. So I go from minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. I pop them in as inputs into the function, which is there. I find my output, and then I use the input and the output as the coordinates of a point. So if you want to think about it like this as your x and this is your y, that's fine. Okay, so you can see I've done it out in the table. I've got all my inputs in a row all the way down. I pop each one separately into the function for x, because that's my input, my x value. And then I'll just do the maths that's involved here. So you can see it's 4 times minus 3 in the top one here. I've got 4 by minus 3 becomes minus 12 minus 3, which is minus 15. So that gives me my output. And then I have my point. My point is minus 3 as the input, minus 15 as the output. And then I do that for all of the range, or the domain, all of the points in the domain. So minus 3 up to 4. And then I can just plot the points. These ones are linear functions, so you're expecting to get a straight line. If you don't get a straight line, you've made a mistake, to be honest, okay? So be careful with your signs, but it's simple algebra, simple substitution and calculation, and then plotting your points. Remember, this is our x-axis, this is our y-axis. So our x value comes first, our y value comes second. I always start at 0, 0. I go wherever I need to, forward or back, to find my x value. And then in this case it's minus 3 is the one I'm showing you. So I found that on the x-axis, and then I have to find minus 15 on the y-axis. So I go up and down till I find minus 15, and I've got minus 15 down there. So that's how I've plotted my point. You can see how I've done it. I draw a dot, I draw a little circle around the dot to make it as accurate as possible. I combine them all and then draw my line. Pencil, I would strongly urge you to use, because it's easy to make mistakes. You can see I made one myself there. So please use a pencil. Please use a ruler. And please be as accurate as you can in the work that you're doing. So that's all I'm expecting from you, okay? The second one, very similar, except we've got two functions, and it was asked to graph them on the same graph, or to plot them on the same graph. So you can see I've done that. I've got two functions, so that one is there, that one is there. The domain is the same for both, from minus 1 up to 4, minus 1 up to 4. I plot in, sub in my points, sub in my inputs, get my output, plot my points. So what I would suggest doing is do the whole thing for one and plot it, then do the whole thing for another one and plot it. And you can see what I've done. I've given them different colours. So this one is the green one, and this one is the red one. And then I've used a red pen and a green pen to plot them. It also asked for the point of intersection in this case, and my graph says that it's about 1.5, 1.5. So you can see it's 1.5, and then I go up about 1.5, and you can find the point of intersection. Now it's not an exact science. It's not always going to be perfect, but you'll get there as close as you can. If you do it accurately and you space out your graph evenly, then you should have no issues. I've made a video on drawing graphs for my physics students. It's on the YouTube channel already, so if you go back, if you're having trouble drawing graphs or you're having trouble graphing, go back and look at that video. Even though it's about physics, it's the same thing, okay? It's no different. It's just telling you how to draw the graph properly, spacing your axes carefully and drawing your points accurately. All right, the last one then, question 6. First part was to do conversions. So they gave you all of the values in miles, you can see them there, and you are given the equation that miles is equal to 1 point, the other way around, sorry, kilometers is equal to 1.6 miles. So to get all of the kilometer values that I have done there, all you had to do was take your miles values and multiply them by 1.6. So 1.6 times 10 gives you 16. So I can see that 10 miles is equal to 16 kilometers. And I did the same for every step along the way. Just multiply each of the miles values by 1.6 and it gave you the kilometer values. It also tells you to put miles on your horizontal axis. So that's why I've done that. I've put it on the x-axis or the horizontal axis, and I've put kilometers on the y or the vertical axis. You can see that I've named the two axes and I've spaced it out as evenly as I could. So then I've plotted the points and I've drawn my line. The questions at the bottom were asked about converting one to another and so on. It's saying, using your graph, find out what 75 miles is in kilometers. So using your graph, what you got to do is like find 75 miles on the graph, which is there. Then I draw a straight line up to where it hits the graph, and then I draw a straight line horizontally to where it hits the axis again. And you can see 75 miles is 120 kilometers. I've also done it in red here and red on the graph, so it makes more sense for you, hopefully. The same there, you can see I've got it in green and I've got that one in blue. Okay, so that's all there was to it. It's asking you there for 140 kilometers, and the green one, so the same idea, but we're doing it the other way around. I go from 140 on my kilometers axis. I go across in a straight line until I hit the graph, and then I go down in a straight line until I hit the axis again. And I'm looking at 87, 88 point miles. If you want to be very specific, you can say 88.5, no problems. Alright, so it's somewhere around there. And then finally, for those ones, it was asking you to find the range between 65 to 75 miles. Now, I used the info that I'd already gotten. You can see in part 2, I know that 75 miles is equal to 120 kilometers, so I don't need to do that part again. You can figure out what 65 miles is using the graph. 65 miles is equal to about 104, 105 kilometers. So that's why I've put that range in. You could also use the formula if you really wanted to. You could say kilometers is equal to 1.6 by 65, and you get your answer. Just pop that into my calculator. 1.6 times 65 gives us 104 kilometers. Okay, so you can make sure of that as well. So that's all there is to it. Hopefully it's a bit clearer and makes a bit more sense. As I said, I've made another YouTube video about how to draw graphs and what you should do to make sure that you're drawing graphs accurately every time. Please look back over that if you're having trouble with it. And fingers crossed you'll be a bit better equipped for these now today. Thank you.